Hello, everyone. This is Jason Jin. I will host this webinar today, and we are so glad to have Joe today to make a presentation about, the structured and unstructured data in prediction model. I'm working with Joe now to, to make the presentation and the microphone working. So it may take a little while. So we are still working on the presentation. So please give us several minutes. If you can hear from me and see on the screen, please, go to the Q&A window. Tell me, you can hear from me, and also you can see the presentation. Okay, thank you for your response. I see, some attendees give me the message, you guys can hear from me. Let me see. Okay. Hey, Joe, I think, can you share your screen? I will stop my sharing now. Can you share your screen so we can start the presentation? But for some reason, I cannot hear from you. Do you know how to call in?
Hi, hello.
Hey, it's very good. Hey, Joe. Okay, it's nice to hear from you. Okay.
Okay,
Hello,
great.
Joe. Are you there?
Yes.
Okay, very good. So let's see. Can you currently I'm sharing my presentation there. Can you share yours so we can start the webinar?
Okay, sure.
I will stop my sharing now, so you can share yours.
Okay.
Okay, very good. Okay, we see your screen. Can you make that full screen? Currently, it's not the full screen. Okay, very good. Everything looks very good. Okay. Okay, so we will start our webinar, today. Thank you, everyone. My name is Jason Jin. I'm the host for this presentation. We are so glad we have Joe Chen today, to have a presentation about, structured data and unstructured data in prediction. This is a webinar organized by IDEAS, International Data Engineering and Science Association. We are a nonprofit organization. We managed a lot of AI conference, online webinar, and also local meetup. Okay, so I will pass this to today's speaker. Let's welcome Joe to start his presentation.
Hi, everyone. My name is Joe Chen. I'm a VP of Data Science at SMG, a service management company. And so here's my background. I would like to share with you. I have 20 years experience in developing solutions for predictive analytics, prescriptive analytics, and quantitative analytics in financial as well as energy industries. I have a PhD in operation research from UCLA and a master in physics from the City University of New York. I first learned mathematical statistics and machine learning from John McQueen. He was a professor of statistics in UCLA before. Now he passed away a couple years ago. And also learned from Harry Markowitz. He won the 1990 Nobel Prize in economics. And my first job was an economist at Freddie Mac, located in Virginia. I also worked for Urgent Financial, TransDelta, Mason, and most recently, First National Bank of Omaha. So the agenda for this webinar is introduction, and then we talk about how to interpret text. Numerical example is provided, and then a summary, question and answer. So in the retail industries, companies have a huge amount of transaction data, customer demographic data, and survey data, and social reviews and macroeconomic data. For the many data, the traditional data type is the structured data, like transactional and quantitative survey and economic data. So now they become more and more important will be the unstructured data. It comes from social reviews and survey open ends. So those past data contain huge amount of information about consumers, their experience as customers, and their consumer journey, and what they concern, and the issues and the problems, and all other comments. So it's a very challenge to most of us is how to build a predictive model with structured data and also unstructured data. So traditional predictive analytics only include structured data. Those will be numerical data and categorical data. So the purpose of this talk is going to talk about how important to incorporate the unstructured data and how to do that. So we know for the variables, there's a different kind of variables. We can categorize them into actionable variables, explainable variables but not actionable, and like consumer emotion and temperature. Those are explainable variables but not actionable, and variables which are not explainable or actionable. So we need to extract features from those data types, like test data, to make it more explainable. So here is one of the some of the industrial research about customer experience. So for good customer with good experience, they typically tell their good experience to fewer than 3 people. And for customer with bad experience, they can tell more than 10 people. That's come from the research from the Gartner. So what that means is that downside risk is much bigger than the upside gain. The bad things can propagate very quickly and have a larger impact. So that's why it's very important to care about customer experience. And consumer in economics and traditional economics study rational behavior of consumer, but the reason modern economies also study consumer behavior like consumer experience, emotion, intent, and effort, and because those are very important factors to drive consumer decision, especially purchase decision and return behavior. So this session talk about how to interpret text. We know there's a lot of text out there, social reviews, and the open end in the surveys. Currently, we just passed 1 billion comments in the survey questions in my company. So how to extract value and information from those text data is very important. And typically, people use rule-based methods, NLP, or NLU, or a hybrid method to extract information from text. A rule-based method will be to use string search, and NLP will transform the text into numerical data based on term frequency, inverse term frequency, and the NLU emphasize more the semantic part of the text. So consumer purchase decision is very important for retailers. So because of that, they want to understand what drives consumer purchase decision and what is their customer journey and experience. So that's why brands, they spend huge amount of effort in the consumer study, especially is try to gain insights from the unstructured data. Consumer text comment, so typically is in the text form. So we also see some comments is in the voice format from the call center, for example, and those can be translated into a text content. So here give a diagram to show NLP versus NLU, and we see that NLU is part of the NLP. However, it emphasizes more the semantic meaning of the text. So that's why it's so important for us to understand the methods in NLU and also learn how to extract text meaningful features like sentiment, emotions, and the effort, product, categories, and so on. And on this slide, I give a very simple presentation about how to how to project the text data onto different numerical dimensions like a sentiment, emotion. Sentiment typically is a positive sentiment or negative sentiment. Emotions can be categorized into eight emotion features, like from disgust, anger, and to joy, and other good experience. The two different spectrums of emotion. So here's a numerical example. We already talked about on the high level about the importance of the unstructured data. So in this example, it comes from real data, anonymous data, but it's a real source. So the data set contained about 23,000 customers' purchase transactional record, and there's 10 feature variables, and the feature variables include closing ID, age of the customer, and the title of the review, and the review text and ratings from the customer, and the recommended flag from the customer. One means the customer recommended the product to other people. Zero means not recommended, and positive feedback count, and department name, division name, and class name for the store. So we're going to do a little bit exploratory data analysis. We look at the customer rated, basically recommended, high recommended is represented by 1, and 0 is not recommended from the customer. We look at the mostly customer recommend the product they purchase, and on the bottom right-hand corner we see the sentiment distribution for these two groups of customers. So we see the sentiment from the customer, they rate the product high, they shift toward the positive sentiment, and for customer doesn't recommend the product, the sentiment is a lean toward negative portion. By the way, the sentiment model used here is a very simple one for indicative purpose. On this slide, we look at customer, well, just sorry, let me pull back a little bit. So this is a customer rating. This slide talk about customer recommendation. We see what is the terms in the text customer mentioned the most frequently. We look at the table on the left-hand corner, and we also can see the weight. So now let's talk about how to model this. So this is indicative flow chart, and it varies from use case to use case, from different kind of data to different situation, business purpose. So it starts with where to get the data cleaning, manipulation, and to the test model. So the test model, what I try to mean is that how to do the feature extraction, extract the usable, explainable variables from the text, like emotions, sentiments, and product category, and other explainable variables from the text. And then we run through the machine learning model, through the cross-validation, and then we combine. Well, let me pull back a little bit. When we do the machine learning, we also incorporate the numerical variables and with the extracted test variables. And then we look at the performance matrix for different algorithms. And finally, we do the testing and reports. And so here is a simplified flow chart. So in the test model, we can look at what is the most important words in terms of variable importance. And we see love, perfect, great. Those are very important words, have a big importance. And comfortable and disappointed is very the negative words and so on. So for the most important variable in the final model, as I mentioned earlier, include numerical variables and projected tests. Projected test will be is a test besides the extracted features from the test, like sentiment. So those will be is a high dimensional data. So typically it can be like 8,000, 10,000 dimensions sparse matrix. We see here from the chart is that the projected text. So that is very important, very dominantly important compared to other data type. I know the data here is quite simple. We don't have a lot of numerical columns, and but we do see the text carry a very strong DNA about customer experience. So here is the performance matrix from the model. So we see that the F1 score is about 70% for the not recommended group because those data is a minority of the data belong to their group, maybe 30%, 20%, that kind of range. Of course, the F1 score is higher for that for the other group, so the recommended group. So these are the typical performance matrix data scientists look at it, and precision and recall, and see the trade-off. So conclusion. So basically, here we propose a method to incorporate unstructured data and structured data into one predictive model in consumer retail industry, and also is applicable to other industry like the financial industry or other industry like insurance, because the unstructured data become more and more important nowadays. And we see the customer feedback data carry a very strong DNA about customer experience. So this numerical example is very simple. I try to use that to illustrate the problem and see and show the importance of the unstructured data. So by the end, I would like to thank you for everybody participating in this webinar, and also thank our organizer ideas, and also thank Jason for his time to organize the webinar. So we still have a lot of time here. I would like to leave more time for question and answer. So let's see what kind of questions we have from the audience. I do see some comments come up. So the first question is, are you using a standard data warehouse or a big data type approach? Okay, so that's a very good question. And so that question, basically, we use big data type approach as well as a standard data warehouse like SQL, depending on what kind of data. So, and the size of the data. So we use both of these approach. The next question is, have you considered what to vet to make your model? Yes, that's a very good question. We do consider that. And so in this demo, I try to make it simple. I didn't use the state-of-the-art package like a BERT or Unfit. So we do use those new models in production, in our research. So let's see if we got more questions here. Okay, interesting. The next question is, could you give us the source of the data? Yes, I can give everybody the source of the data. It's nothing secret. It's come from Kaggle. It's not a competition, but some company post the data on Kaggle. Okay, next question is, there is a perception that unstructured data and big data tools are faster time to completion. Do you see that? You still have to clean the data and have a pipeline at some point, it seems. Well, we do need to clean the data, and it's much more complicated than I show here. So the reason for data cleaning is that, for example, like social review or survey data, there's a lot of response are not reliable. It may be manipulated by somebody, similar to the fraud in financial world or insurance world. So in that case, we had to identify the clean up the untrustable data from all the data, and on the other hand, just for trustable data, we still need to clean the test data. We still need to clean the test data because we need to make sure there's no spilling errors, and sometimes we need to do a lot that kind of cleaning of data. So I still think data cleaning is important for text. Of course, for numerical data is very important, and we all know of that. How to deal with missing data, how to those sort of methods is very applicable to numerical data. Just to try to summarize for this answer, test cleaning is still important. So as well, I mean, is similar to the numerical data. I try to summarize my answer. So which machine learning technique do you use, and which one was the winning model? Well, we use a different kind of machine learning model. So sometimes there's a trade-off between winning model, I mean the more precise algorithm versus the more simpler but explainable algorithm. So there's a trade-off there. We typically use different kind of algorithm, from the simple one like logistic regression, naive Bayes, to a little bit more complex algorithm like random forest, XGBoost, and so on. We try different algorithms for sure. And also we care about explainable result. So by the end of the day, we need to provide actionable suggestions to management. So that's why we care about the explainability of the model. And so the winning model, so it depends on the use case. So we cannot say one algorithm is going to be dominate in all the case. So so that's my answer for that question. Okay, next question is, do we get to access or see the code and data? Okay. So the data, as I mentioned, is available in Kaggle. And for the code, currently I haven't summarized. I'm writing the paper. So still, I would like to delay a little bit to share the code with everybody here. Next question is LDAVs a good way to interpret the topics? Well, I don't have a good answer for that. So interpreted the topic here, I basically not to rely on an algorithm to interpret the topic. We know there's some algorithm for model interpretability. So like a line. However, here I try to emphasize for feature extraction, extract explainable variables from the text. So that's why I try to answer. So each of the process can be a separate model, like a sentiment. If we try to extract sentiment from the text, so itself is one model. So there are different algorithms can do that. And for emotion, there will be another model can do that to try to categorize each test data point into 8 emotion category. And so other features can generate from the test will be a product category and intent of the consumers and the efforts and so on. So why I emphasize this? Because most companies care about that. So we try to present the data and as well as the final results in the format is consumable to those companies. So that's the purpose. If we simply use an LP, and then by the end, so people will ask what is the driving factors in the model. So that may not be easy to answer, number one. Number two is that because it's a high demand show for the test data type, after we transform the test data into document frequency, inverse frequency, something like that. Term frequency, inverse document frequency. Translate that into a multi-dimensional matrix, so the dimension is very high. So it's not optimal, and also it's not the right way to do it, to combine those high numerical dimension with numerical data. So that's not good way, even though it looks very naive. And the reason is that when we try to do that, what is the implication? And basically, it implies we treat those high dimension data is the same way as traditional numerical data. So, so that's my personal opinion for that. Next question is, are you using any notebook for front-end querying of data, Jupyter, etc.? We typically, it really depends on. In terms of query the data, we use SQL and other methods. It depends on where we store the data. We store the data in a relational database or in Hadoop, whatever. So we do use a Jupyter notebook for some of the development because of the ease of presentation, and so that should not be restricted for development purpose. So that's my answer. The next question is, based on what have you decided to choose your variable? Also, semantic is very obvious. Others are not. Okay, that's a very good question. We select a variable based on what most companies care about in the space. Yeah, for example, in the retail space, and so what they most care about for consumer, about emotions and intent and effort and so on. So we extract the features in that way, what companies that care about, to make sure the features we extract from the test data is explainable. Of course, if it's actionable, even perfect. So that's more complicated to extract those, because for actionable features in the test, so because of the sparsity of the test data, so those actionable features will be it's not going to happen a lot of time in the business case. Very often we aggregate those different information into a more aggregated variable. So that's what I'm trying to do. So the next question is, what is your team size? So my team size is not very big. It's 5 to 6 people. However, we have a very big engineering team, because we are making softwares and making platforms, consumer platforms. So so for that reason, we don't have data engineer in my team, because there's a lot of overlap. So my team size is quite small. So the second part of this question is, trying to gauge how large a team is needed and what is their skill set. So that's the second part of the question. Well, in my opinion, the size of the team is depend on the business need, and I try different members, different skill sets in my team in different companies. And in some companies, I had data engineer and also software engineer combined, and also have machine learning engineer and data scientists and so on. And in some company, I have business analysts in my team also helping the work. So it's really depend on the company, what kind of business it is, and also depend on the rest of the other teams. Try not to create too many overlaps. So I try to make sure the utilization of each of my team members at least can be like 80, 90%, that kind of range. So I make sure everybody is fully utilized. If you see somebody's utilization time is 50% or below, that's a concern. So that's why I'm saying, so what kind of team member and skill set in the data science team is really depend on the company, the business, and other teams outside of data science team. The next question is, do we get a presentation and the recording? Well, the presentation should be available. I think Jason has a copy for that. And for the recording, I think Jason can answer that question. I think I answered all the questions. So are there any more questions for me? I think those questions are already answered. So, any more questions? Jason, do you want to talk more? So, it looks like there's no more questions. My personal email address I cannot provide. Either you can email to Jason, maybe it makes more sense. If you have more questions, email Jason, and then Jason can forward to me if you have more questions. Otherwise, we're going to stop here. It looks like there's no more questions. Thank you, everybody. Thank you.